factors that affect soil erosion. Plant cover. We really like cover crops. It really helps reduce erosion, like a lot. Having a plant there really helps reduce erosion. It helps the rainfall pattern to not be quite so intense. The roots keep it there. So many delightful things about plants that keep soil in place. Again, topography, this is what most of central Illinois looks like. These rolling hills, you could flatten that out a little bit and make that a little bit nicer. You could plant some trees so you get less wind erosion. This is just the tilled, so much tillage. You need to dial down the tillage. You need to make sure that this is flatter. You can plant some cover crops. This would reduce some of this terrible erosion. You could direct the planting of rows in the opposite way. There's a lot of things you could do here to prevent this. This is unnecessary erosion. No-till something. Plant some cover crops. Get this flattened out. Many, many things you can do to prevent that. Physical properties. Like we said in class on Monday, soil has different properties. Central Illinois, Ukraine, Iowa have some of the best soils in the world. It's deep organic matter, and they're less likely to erode, and they're slowly permeable. They do need tile, so they do need drainage underneath because they hold water so well, but it's really excellent soil. Wind erosion, we don't get as much of that here because we do have trees and grass. If you go to Kansas, and if you were reading on the news, Illinois had some very serious wind erosion going up Interstate 55 a few months ago, and it caused some accidents in which people were killed. So it's level land. There was nothing planted there. They were harvesting, planting at different times, and the wind just got to where you couldn't see on the interstate, and it was a problem. And so they're talking about ways to combat that. The things that I just said: plant a cover crop, keep something on the field at all times, and you won't have wind erosion. You don't have wind erosion from grass fields because the grass and the plants keep the soil where they are supposed to be. Vegetative cover is best. If you must do tillage, do it when there's not high winds. That's another factor that happened in the accident over the summer. Leaving windbreaks, also some trees and grass and some things in between also help with that. Again, conservation programs. So conservation programs preserve and extend the life of the soil. The Soil Conservation Program began in 1929 with Congress establishing a soil conservation service and experiment stations. In 1933, there was the National Resources Conservation Service, NRCS. Both of these things are dedicated to helping land and soil stay healthy. Poor tillage practices in Texas, Oklahoma, and other of the prairie states like Kansas caused Black Sunday, which was the Dust Bowl, April 14th, 1935. There were just black storms of wind. It blocked out the noonday sun. As you know, noonday sun is pretty intense. And just an insane amount of topsoil ended up blowing into the Atlantic Ocean. Dust darkened the skies of Eastern City for months. So that's when we decided to start doing something about soil erosion. Another thing you can do is just have these delightful grass waterways. See how the grass prevents the erosion? Strips of land, this is strips of land in the field that are permanently planted with grass, and they conduct water, and as the water goes through here, it actually gets cleaned. The microbes and the plants help to filter out the nitrogen and the soil, and by the end of here, it's actually pretty clean. So this grass serves as a filter also. Contour tillage, so this is tilling it this way and making little ridges, so the water has to run down and hit all of these areas of planting. So that's just the way that you plant around a hillside. Contour farming is actually making little ridges in there. Strips of tillage rows with alternate strips of solid planted crops. Terraces, Terraces are low mounds. You will see a terrace, it's like a little ridge, and then it'll drop down and there's another ridge. That's a mound that follows the contour of the hill. It retains and redirects water. It can be used in landscapes, and you can sometimes see it on golf courses, and it's very helpful for conservation. No-till farming, again. the old crop is not tilled before you just plant right into the residue from the previous crop. You can use herbicides actually to destroy the weeds and then plant right into it. That residue serves as a mulch for both weed control and erosion control. The ecosystem there with all of your earthworms and microbes, it's not disturbed, so they're happily munching away at the old residue from last year's crop and providing you with lots of great nutrients. Roundup Ready corn, Roundup Ready soybeans is really helpful to this process. It's almost impossible for organic growers to use no-till because they have to use cultivation for weed control because they can't use pesticides. Artificial soil. So this is our potting mixes. This is what we were using in the greenhouse. You need to know what kind of plant you have and what kind of soil it requires. Or if it requires soil at all, you might be able to grow it hydroponically. So again, you even saw in the greenhouse, we have potting soil for our succulents that's well drained because succulents, like my cactus back there, they don't like a lot of heavy soil. When it rains, they don't need much water, and so they don't like much water. They like a lot of oxygen. So this is a great way, just using potting mixes and knowing what you need for easy management for water and fertility purposes. Golf courses and athletic fields, this is intense, right? You have people getting fired every day because there's a bad spot in the grass. So this is turf grass management is probably the most intense of the plant sciences. They make the most money, but the turnover rate is crazy, and the anxiety. You have to have beautiful, playable, there can't be any brown anywhere. So you have a lot of fertilization. You have to know your soil type. You are constantly out there making sure that it looks correct. Again, factors mostly are just native. So what kind of native soil do you have there? What kind of particle size? Are you looking at sand? Are you looking at clay? Are you looking at a good loam soil? What's the structure? Is it well drained? Is there compaction? What's your cation exchange capacity? What's your pH? There's a lot of things to consider. Again, when you're in a greenhouse, how much sand, how much peat moss, how much vermiculite, perlite, core, other things, fertilizer, if you want some ash in there, if you want some biochar in there, there's a lot of new things out there that are coming down the pipe. Manufactured, you want to avoid compactions. You want to avoid shoving the soil in there and then putting your plant and then shoving more soil on top. You super don't want to do that. You want to avoid compaction, and you really want to avoid alternating particle size where you have like one, then two, then another one, then another one. You just want to have it kind of the same. So mix your soil very well. You can put rocks at the bottom or something to help with the drainage, but the soil, you kind of want to mix it a little bit if you want the roots to interact with it the same. You can do a custom blend. If you are a huge nursery and you grow like azaleas, I worked in an azalea nursery. We had an azalea blend that we had made just for us. Then we recycled it by fumigating it in between. And it had a very specific fertility, a very specific pH, a very specific water holding capacity, specifically for the azaleas that we grew at that nursery. Areas where irrigation is not needed still have to consider how precipitation affects it. So you need to manage your soil and determine how water is going to affect as your soil runs off. Irrigation, again, a practice over 4,000 years old. The Nile, the Tigris, the Euphrates, the Fertile Crescent. I'm sure you learned about this in history. What really helped civilization in different places were controlling the water, ability to irrigate. So controlled by dams, treadmills, or other ways. And that allowed us to enter into societies where we didn't have to be nomads because we could control the water, therefore we could control the crops. Again, things to consider: pH, alkalinity, how does the soil look? A lot of these are soil tests. Again, when you're irrigating, are you using salty soil? Is that going to actually accumulate into the root zone? What kind of salt are you irrigating with? This, again, happens mostly near the ocean. Like if you think California, they definitely have to worry about these issues. Irrigation, this is a flood irrigation, it's called. It just basically, you have a little bit of a slope so that you irrigate it here and it runs down. This is called flood irrigation, flat, level. You can also have irrigation in greenhouses where it just sprays on top. shallow, short, and some can contain liquid fertilizer.